Okay, so today's lesson is on scientific notation. This should be a review from previous science or math classes. Remember, scientific notation, fill in this blank real quick, is simply a means for expressing and working with really big or really small numbers, which is something we do often in chemistry class because atoms and molecules are so tiny, we end up with very large numbers of them. So often we are writing in scientific notation. So these numbers are going to be very large, meaning lots of zeros at the, hold on, very large, we can spell, or small numbers. Okay, so scientific notation is going to have, right here, you're going to have a coefficient. Okay, so there's going to be a number here. It could be have a decimal and then some numbers following it, but there's only ever one number out in front of the decimal. Left of the decimal, you'll only ever have one number there. Then you're going to have a times sign, and then you have a base of 10, and then you're going to have, and right there as an exponent, you're going to have some number. So for example, you might have 3.2 times 10 to the second. Okay, that tells me this times 2 to the second tells me that I would, if I expanded this, I'd move the decimal point 2 times to the right to expand that. So that's really 320. Okay. So the rules for writing scientific notation, you have the coefficient must be greater than or equal to 1 and less than 10. So, you could have the number 9, you could have 8.5. So you only ever have one number out in front of the decimal. The base must be 10, and the exponent must show the number of decimal places that the decimal would need to move to change the number to standard notation. Negative exponents mean the decimal is moved to the left when changing to standard notation. So up here, because this is positive, I know that this is a number that is greater, that is a big number. So I'm moving it to the right. If I had 3.2 times 10 to the negative second, that means to expand this, I'd have to move it 2 times to the left. So this number would actually be 0.032 because I would have moved the decimal 1, 2 times, and just, I usually put a 0 out in front of the decimal so you know that dot is not a random dot there, that is a decimal point. So I usually just put a 0 in the ones place as a placeholder so you know where that decimal belongs. Okay, so let's look at some examples here at the bottom of your page. Okay, so when we scroll down here, go back up, go up. Stop there. Okay, so some examples. Where you have to keep the precision of the numbers. So first thing you're going to look at is see if these zeros are significant or not. Since there is no decimal, these are not significant numbers. So when we rewrite the number in scientific notation, we can drop those numbers. Since there is no decimal, you have to imagine where that decimal would be. It would be back here at the end of the number. So I would have to move this 1, 2, 3, 4, 5, 6, 7, 8 times to the left to put it into scientific notation. So this number is 3.2 times 10, and it's a big number, so you get an 8 there. Okay, there's a decimal, so this 0 at the end is significant. Remember, if there's a decimal, your eye jumps to the right to find where the precision runs out. So these digits right here, 4, 2, 5, and 0, are all significant. To move that decimal point 1, 2, 3, 4, 5 times to the right, it's a number that's smaller than 1. So this is 4.250 times 10 to the negative fifth. Okay. 300, we've got a decimal at the end, so these zeros are significant. we would move the decimal 2 times to the left. It's a number greater than 1, so this is 3.00. So I kept those zeros there. Times 10 to the second. Okay, over here on the right, we've got these two numbers that are significant. So we have 5.6 times 10 to the negative second, because that's a number smaller than 1. Just the number 10, no decimal. This 0 is not significant. We move it 1 time to the left. So this is 1 times 10 to the first. Not that you would ever rewrite 10 as in scientific notation, but it is good practice. Okay, we have a line of zeros, but there's an overbar on this one. So this is where the precision runs out. The rest of these zeros we can drop when we rewrite the number. So remove it 1, 2, 3, 4, 5 times to the left. So 2.3, and I need to keep that 0 because it is significant, times 10, and we moved it 5 times, so that is a 5. Okay, and that's a big number, greater than 1, so you're going to have a it's going to be a positive number. So big numbers have positive exponents. Little numbers have negative exponents. All right, we're going to convert these to decimal form. We have a negative exponent here, so it's going to be a little number. We're moving it 2 times to the left. Okay, so I'm going to put a 0 here as a placeholder so I know where my decimal is. 0, 4, 7, 3, because I move it 2 times. 1, 2, put my decimal there, fill in my 0. Okay. Down here, we have 2.00. These are significant zeros, times 10 to the fourth. So I need to move this decimal 1, 2, 3, 4. Fill in zeros here. This is the last significant 0. So we have 2. I'm going to keep these 2 zeros. This is my last significant one. Then I have to put in the last 2 here. Now down here, we just have 2 times 10 to the negative fourth. Here's your imaginary decimal point. Move it 1, 2, 3, 4. Fill in all your zeros. So we need 2, and we need 1, 2, 3, 4 zeros. There are no trailing zeros, so none of these zeros are significant. So we will not put a bar or a decimal point in there. Okay, you guys are going to do the practice on the next page. So if you could pause the video, and then I will put the answers to these. So you can try these on your own. So you're going to pause and then try these. So 3.04 times 10 to the fourth, 1.50 times 10 to the negative second. So I move this 1, 2, that 0 is significant. These are not significant, so I did not add those. 3.208 times 10 to the third. Okay, in decimal form, I move it 3 times to the left, so I need 0.0043. This is a significant 0. We're going to need an overbar. 750. Now moving it 5 times, I need to add 1, 2, 3 zeros. Put a bar over that 0. Okay, I'm going to put a 0 placeholder. I need to move this 6 times, so I need 5 zeros out in front of the 8. 2, 3, 4, 5, 8. Now this is a significant 0. Need a 0 there. Okay. So when we move in and out of scientific notation, we have to maintain the precision of our numbers because they are measured numbers. You can try the practice on the scientific notation practice page.